The 2009 Junior Cert Higher Level question 4 here on solids in contact. No developments mixed in with this question this particular year, so not a bad question at all, I think. The elevation and incomplete plan of a solid A and a sphere B are shown. So I'm going to start off just doing a little bit of highlighting a solid A. Strange, usually they'll tell us what the solid is. This time I suppose they won't, because what is it? It's a half a cone. The half here at A at this side is a half a cone, and the side along this left side of it is a half a pyramid. So there's a pyramid around here to the left side, and a sphere B. So nice and simple sphere dropped in. Solid A consists of, okay, here it is, solid A consists of a semicone and pyramid, which is cut as shown in elevation. So it's cut off at this height right here. Top of it doesn't actually exist. Also shown is a 3D graphic of the solids before being cut. Draw the given elevation and complete the plan of both solids. So the elevation exactly as it's given, complete the plan. So I'm guessing what's missing there is this cut. It's not actually shown there in any way. Draw the projections of another sphere which rests on the horizontal plane and is in contact with solid A at point P, and then show all points of contact in plan and elevation. So interesting question this time. I'm going to start off in the plan, and I'll just draw the base of the half cone, half pyramid here that we have, and I'll start off with my radius 45. I'll draw that. I'll move up to the elevation. I'll draw the elevation of that object, and then time to drop in the sphere here in this position. Find my point of contact, of course, and bring the sphere down, draw it in plan with the point of contact shown. Then we will have a look at point P and drawing the projections of the other sphere. I might just, while I'm drawing the elevation and plan, I'm going to get this cut, this horizontal section cut done as well and brought down here. So that's the plan. Just in case you're wondering, when I start drawing through this, I'm going to draw this question on an A4 page, so it's going to look really, really full on the page, but it will fit on the page, no problem. Let's get going. First thing I'm going to do here is just maybe just off to the right hand side of center of this A4 page, so I'll just come in about 180 there, or maybe actually, you know, 170. And it's about 170 there. I'm going to draw a vertical line up through the page, and I have very little space to deal with here. I only have about 10 mil. It's a radius 45 plan. I'm going to go 55, and that's the center of the plan. I measure back down 45, and that will give me a center and a point on the circumference of the circle. So I can go ahead and draw my circle. Onto that circle, I can just get my 45 degrees set square. And if I split that circle through the center, I can break this object up into pyramid on the left and the cone on the right. So there's the pyramid to the left and the cone to the right. I'm not going to go over the cone because I know that some of it is going to be hidden under the sphere. Again, I have very little space here, but I can afford to leave a 10 mil space in between the views. And the elevation, there was two heights given, 55 and 35. So 55 for the cut section plus 35 brings me up to 90 total height. I'm going to bring up the extreme left and extreme right of the plan, and just lightly again draw it up here in elevation. The elevation finishes at the 55 mil mark. The base can be also drawn heavy, and I do know that that is an edge where the two objects meet, so that's going to be heavy. I also know that the sphere is touching up against this guy, but it's not coming in over it, so that's heavy. And as far as I know, I'm not certain yet with this one because there is another sphere to go in, so I'm just going to leave that one. I didn't go very heavy on that. That's the first part of the question answered anyway, but would it be, I think the best thing might be now to just go and draw the section cut. So what does a section look like in this object? Well, when you have an object, a regular pyramid or cone sitting on the ground, whatever shape it makes on the ground, if I rise the ground up and put another horizontal section through, it's going to make the same shape up top. What do I mean by that? Well, first of all, as I bring a horizontal section plane up from the ground up to 55 millimeters right here and cut, the shape is going to be the same shape as this makes on the ground. What shape does it make? It makes these two lines on the left, and it gives us the curve here on the right. I'm going to look at this a different way now. I'm going to say 0 being the apex down to point number 1, which is here on the ground. Well, that edge gets cut here. Okay, so that edge gets cut here. What does that mean? That means that what remains of that edge is there, and that's all. The generator, you call it a generator on a cone that goes from point 0 up top down to point A on the ground. A gets cut here. So the 0 to A, the generator or the line on the curve, gets cut there. Now, that doesn't mean this time that I heavy in this edge because it's a cone. There's an unlimited number of these straight lines on it. So I'm not going to heavy it in. But that is all the information I need. And we're going to use a little bit of theory and the principle I just talked about. As we horizontal section through this object, it gives us the same shape as the base. So you're parallel to the base from a point on the cut surface. You're parallel to the base again from a point on the cut surface. And the final one, we're going to be this time concentric with the base, so having the same center point through the cut point there, and I'll just check it left and right now, make sure we're accurate here, and there we go. That's what it looks like when we cut the object, exactly as shown in the animation. I'm going to just drop in the extra two edges, one here and one down here. So that's what this cut section looks like. Once I know what space I'm dealing with, I'm going to just add a little sketch in here, which hopefully even explains that further. The further up that plane, so at the moment that plane's at 55, if we increase and the further up we push that plane right up towards the top, the smaller the resulting cut is going to be. The further down I pull the plane, the larger the cut would result. So there we go, that's the first part of this. Well, actually, in fact, isn't it the last part of it? Where is it? Or draw the given elevation and complete the plan of both. So I've the elevation of one and the plan of one complete. Now it's time to find this radius 32 sphere dropped in there, touching the edge and touching the ground. Radius 32. What do we do for that? Well, we want a circle that touches two lines. If it's touching the horizontal plane, the ground, if it's touching this line here, I need to bisect. By bisecting this angle, I'm going to find the path of every possible circle that sits in that corner, touching the line and the ground. So there we go, that's step one. Step two then is to pick a position, anywhere at all, and draw your vertical line, and put this sphere sitting on the ground. What size is this? Well, it's 32, isn't it? Put the sphere sitting on the ground and roll it in. So I went from the ground here up 32 millimeters. From there I rolled it in and I found the correct center point of the sphere. We're not quite out of the woods yet. Before I draw a circle, I need a point of contact. In this case I need two. The point of contact that mates with the ground is just going to be straight down there. of course it's going to be perpendicular to the ground, that projection is. And the point of contact it makes with the edge here is also perpendicular. So I'm going to go and set with the angle of the side of this semi-cone. I'm going to slide down and I'm going to draw the normal. 90 degrees right there. That's all the info I need. Put the compass on the center, open it to the point of contact. Check that it touches both points of contact perfectly, and once you're happy, drop in that sphere size 32. And there we go. That is a point of contact, POC. We don't usually talk about the point of contact on the ground there, so we'll leave that one for now. As it showed us in the question, as it's set out, the center of the sphere, of course, has to line up in every view, and the sphere is directly beside, touching this external or extreme generator, so it's straight out. That is the center of the sphere. I didn't change the setting of my compass from when I did the elevation, so I'm going to drop the compass down and I'm going to draw that sphere. So where is the sphere? Is the sphere solid? Yes, it is. It overshadows, it goes in over the base of that cone, and there we have it. That's the sphere. I'm going to just take a little bit of the weight off the cone right there. I'm going to reset the size of the cone again and heavy in a portion and then dash a portion for hidden. So it looks so much neater once you've it dashed in as well. The last thing here on the right hand side is take your point of contact down. The point of contact between any two round objects lies on a line joining their centers. So it's going to lie on that line right there, giving us the point of contact. Now that of course only works when we're looking down the plan of this object. Up here it appears as an edge view, so we see a normal. So it still lies on that extreme generator. From here going out to the edge gives me my point of contact. Time to, before everything falls, time to just have a quick look back at the question, see what we've been asked. Semicone and pyramid is fine. It's cut as shown in the elevation. We've done that. Also shown as a 3D graphic before the cut is fine. Draw the given elevation and complete the plan of both solids. Done. Draw the projections of another sphere which rests on the horizontal plane and is in contact with the solid A at point P. So first of all I have to find point P. It lies on a 45-degree line, 5 mil up there, or 5 mil in as it appears in plan. So on a 45 mil line, 5 mil in from the edge. That's not a true 5 mil, of course, that's just the way it appears in plan. So down along a 45 and 5 mil right there. That's point P. I'd like to find point P in elevation as well. That's clearly we're going to have to do that. So I'll project it up. I have two options really. I can either find the line that P is on, which is a line that goes along this surface. We'll ignore the fact that it's all cut now for a while. There's a line that goes from O, hits P and drops onto the ground. So that's a line on this surface here. If I want to find this that way, I can take this point which is on the ground up and I can draw that line. And along that line, I'll grab point P. So that's a handy way to do it. The second way to do it is using my section. So just to practice what we've just done a while ago, if I wanted to section, I'll take the angle of the ground and I'm going to take a section through point P right there. So I've cut the object again. And I've cut it so that it solves a little part of the problem for me. That gives me a point on the extreme line here. And then I'll just show my cut once more. And that gives me point P. So there it is in plan. There it is in elevation. To finish off this question, I need to just find and there is only one answer to this, I need to find the one sphere that sits on the ground, touches the ground here, and touches point P. Okay, that's there's only one possible answer, but there's two ways of getting that answer. And the first way, and I think this would be the common one that I'd see now if I was correcting a question like this, the first way would be the way that we're used to if we're solving these questions where you have to roll it around to the front. Someone would do it this way, where they bring it up and they use that point right there, and they come off and they bisect the angle and go off as normal. Absolutely fine. It's a valid way to do it, and I will actually go back and do it that way as well. But the way I prefer to do this is this way. I'll take the angle of the line on the ground here, the base of this surface, and I'm going to view up along that line. So that I'm looking at this whole surface here now for a moment, and I'm going to add some colour onto that surface to make this a little bit clearer, hopefully. So taking that surface and viewing up along, so we're going to move our position instead of viewing in at normal elevation, and we'll view in an auxiliary elevation. We'll look along the line that lies on the ground right there, so we'll view up along that line. I'm going to act like as if this surface hasn't been cut, and I'm going to go right up along there to the apex of it. I'll take the apex up with me. I will just bring my section cut as well. That might come in handy, but just for clarity we'll bring it. I'm going to put in my x1, y1 line, which is perpendicular to my projections. This line here is on the ground. It has no height. It just sits right there on the ground. So that stays on the ground. I just moved myself around from my normal viewing position around to the side. The points did not change height though. So the height of the apex is still the height of the apex. I'm going to have to bring my projections a little bit further now. That's the apex up there, which means I can see that green surface as an edge view right there. Okay, so really handy one to know. I'm going to label it as the edge view of green surface. Now, where's point P? Well, point P projects straight from plan up and hits the edge view right there. That's point P. Now I can go ahead and find that sphere. So, first off, the sphere has to be in the corner touching both lines, so I'll just bring my compass in and I'll bisect the angle. And the second thing, just like I did over here on this side, I'm going to set the angle of the edge view, and I'm going to slide out, hit point P, and go for a normal. So, right there, we go normal. That gives me a point of contact and a center. Although I don't need to draw this, I'm going to. I don't actually need to draw this in this view up here, but I do know that that's the center of the sphere. That's the point of contact there. If I set the exact, see if it hits the ground perfectly, and it does. So it hits the ground, it hits the point. There we go. That's the sphere. I'm going to bring that back down to plan. So just the center point is the only important one I need, down to plan. It's very close to the edge here. Where does it lie? Well, it hits the wall here, it hits the slope surface directly at P, so whatever angle the surface is at, I need to go 90 degrees to that, using the 90-degree edge of my set square again to guide me. And there we go. That gives me, just outside the circle right there, the centre of this sphere. I didn't change my compass setting. I should find that it's just about getting in over point P. Next, and I should have foreseen this one, I suppose, I'm going to just take a little bit of the colour off that guy right there, and I'm going to show hidden detail on that baseline, just the portion of it that is under the sphere. Now, what's the final step? The final step is, if I have the centre here in the plan, I need the centre here in the elevation. Okay? I still have my compass set to the correct size. Well, the height from the ground up to the centre has to be the same here. Height from the ground up to the centre. And once again, we put our compass on the centre, it hits the ground, and we draw our sphere. And what you might realise, just like down there in plan, time to get rid of some of my colour that I have here, some of that green that was helping me to see what was happening, and bring the set square back and add in my hidden detail for the edge right there. And there we go. So I hope this video has helped, and if it has, just drop a like to the video and a comment if there's any more you'd like to see. Thanks very much for watching.